Place value. Our number system. We generally have 10 fingers and 10 toes, which makes it easy for us to count to 10. Many historians believe that this is where our number system came from, and it's called base 10. The digit furthest to the right is the ones place. In the number 247, there are 7 ones. The middle digit is the tens place. In the number 247, there are 4 sets of 10. The digit furthest to the left in 247 is the hundreds place. In this number, there are 2 sets of 100. Therefore, there are 2 sets of 100 plus 4 sets of 10 plus 7 ones in the number 247. So again, that's 200 plus 40 plus 7 is equal to 247. Base 10 blocks are manipulatives that can be used to help students understand the abstract concepts in mathematics. They come in ones, tens, hundreds, and thousands, and they're especially helpful in helping students visualize numbers that are in base 10. In the upcoming slides, we'll show how base 10 blocks can be used to help students understand place value. In the previous examples, we've talked about place value to the hundreds place, but it also extends to the thousands place and the millions and beyond. Base 10 blocks get larger as you move from right to left on the place value chart. For example, in the ones place, we just have 1 block by itself. In the tens place, we would have stacks of 10 blocks. In the hundreds place, we will have a rectangular prism that consists of 10 by 10, and they're only 1 deep, of cubes. So that's going to represent 100. And then in the thousands, we're going to actually think about how that would be represented. Take a moment to pause this video and think about what the thousands will look like in terms of base 10 blocks. When you're finished, you can unpause the video to see the answer. Since the hundreds are represented by 1 row of blocks that are 10 by 10, like I said, they're 1 deep, the thousands is actually 10 of these hundreds lined up in a stack, so it looks like a cube. It's going to be 10 by 10 and then 10 deep. So it's a cube that has 10 across, 10 up, and 10 deep. Look at the base 10 blocks to see how each place value is related. So the question from the ones column to the tens column is 110 is how many times larger than 1? The answer here is 10, because it's a stack of 10 single blocks. 100 is how many times larger than 110? Well, it's also 10 times larger than the tens column because it consists of 10 stacks of 10 blocks. And then how is 1,000 related to 100, or how many times larger is 1,000 than 100? It's again 10 times because it takes 10 of these sets of 100 to get 1,000. Let's try to represent this pattern using equations. If we have 10 ones, they make 110. In other words, 10 times 1 is 110, or 10 ones. That means that 10 times 1 equals 10. And we can also say that 110 is 10 times as many as 1. In our next example, 10 tens make 100. This means that 10 times 10 is 100, or 10 tens. And the number sentence to represent this would be 10 times 10 equals 100. So we can say that 100 is 10 times as many as 10. This gives us the following relationships for each place value. Every time we get 10, we bundle and make it a bigger unit. We copy a unit 10 times to make a larger unit, and if we take any of the place value units, the next unit on the left is 10 times as many. In other words, 110 is 10 times 1 or 110 is 10 times as much as 1. 100 is 10 times 110, or one value of 10. You could also rewrite that as 10 times 10. And then 1000 is 10 times 100, and you can also rewrite that in numbers as 10 times 100. Below is a place value chart up to the millions place. Take a moment to pause this video and answer the question, what other patterns do you notice? When you're finished, unpause it to have the answer revealed. If we examine the columns, we're given the ones column, the tens column, and the hundreds column. Then we get to the thousands, and then the 10,000s, and the 100,000s. I'm noticing a similarity with these first words and in these columns. We can also see that every 3 place values we have a comma. So you have the title of your place value, and then the tens of that and the hundreds of that. This one is the thousands place, then we have 10,000s and 100,000s. Then we have another comma, and the next one is millions. Based on this, what do you think would come after to the left of the millions place? Take a moment to pause this video and answer the question, and when you're done, unpause it. Since the pattern continues every 3 with, for example, thousands, 10,000s, 100,000s, we have millions. The next one will be 10 millions, then 100 millions. So it keeps going with whatever that new title is called. Then it goes 10 of that and 100 of that, and then it gives you a new unit afterwards. Now let's complete an example with tally marks instead of base 10 blocks. The tally marks can also be used to represent how many of each place value we have. So if we examine the tallies that were given, in the thousands place we have 3 of them. So we could start writing 3, and then because this is a new value, we use a comma. Then we have hundreds, and there are 5 of them. So I'm going to put a 5 there. There are 4 tens. So I have 40 of something, and then I have 1 1. So this number in numeric form will be 3,541. If you have 9 more ones, what will the new number be? Well, let's actually figure that out. We can also use the place value chart to show our work. So 9 more from here would be 9 extra ones. So I'm going to add those in, and I'll put them in purple so that they're different in color. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. When I added 9 to the 1 1 that was in the ones place, I actually now have a 10. So I'm going to add a 10 or a value to the tens column, and I'm going to erase all of these, and we're also going to cross out this extra 1 that we had before because now it no longer exists. So our new number will be 3,000 still, 500, but then it will be 50 because I have 5 tens and 0 ones. And let's click to see if we got that as the correct answer. And we did.